There are several properties that involve chord and tangent segments in and within circles. Here's one theorem. If the diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. So we have diameter UT. It goes through the center, so it's a diameter. We have the chord QS. Because the diameter is perpendicular to the chord, it means that the chord is bisected into two equal parts. It also tells us that this arc is bisected into two equal arcs. Another theorem. In the same circle or in congruent circles, two chords are congruent if and only if they are equidistant from the center. And let's review distance between a point and a line. It's the shortest distance from the point to the line, and it must be perpendicular. That's what it ensures that it is the shortest distance. So let's say that these two segments are congruent. That tells us that the chords AB and CD are equidistant to the center, and therefore the chords themselves are congruent. The if and only if in this theorem tells us that the concept works backwards as well. If I started off knowing that the chords were congruent, then I could conclude they were the same distance from the center. Next theorem. In a plane, a line is tangent to a circle if and only if the line is perpendicular to a radius of the circle at its endpoint on the circle. And we call that endpoint right here a point of tangency. Because we see line L is perpendicular to radius QP, that means L is a tangent to the circle at point P. And next theorem. If two segments from the same exterior point are tangent to a circle, then they are congruent. So we've got two segments, these are lines, but we're talking about the segment pieces that are formed. We've got from point S two tangents. I can see that we have tangents because of the perpendicular nature to a radius of the circle. When that happens, the two tangents are congruent. Let's do some examples. Find the value of C. So we look at the diagram, we can see that we have a diameter, and we can see that the diameter, right here, is perpendicular to a chord. That means that the chord is bisected. And these two halves are congruent. That means x is equal to 7. For the record, we would also know that this arc and this arc are congruent. But wait, there's actually more. We could also conclude that this arc and this arc are congruent. A diameter being perpendicular to a chord creates a lot of symmetry, which then creates a lot of congruences. Example 2. Looking at the diagram, we can see that we have two chords that are congruent. Well, we're going to conclude they're congruent. They are, but they do end up to be congruent because they are equidistant to the center. Equidistant involves being perpendicular. Because the chords are equidistant to the center, the chords are congruent. Which means x is equal to 15. Third example. You always have to read. We are told that segments A, B, and AD are tangent. So that means we do have perpendicular to a radius. But what's more important for us is that if we have two tangents to a circle that share a point outside of the circle, they are congruent. And we will set up an equation to solve. 3x squared minus 11x is equal to 4. This is a quadratic. That we will set equal to 0 and factor. Okay, so we've got 3x times x is 3x squared, 1 times 4 is 4, and we need 12x, negative 12x plus 1x to equal negative 11x in the middle. Set each factor equal to 0. And solve for x. We get x equals negative 1 divided by 3, and x equals 4. Since x is a value that represents a length, we will eliminate the negative and keep the positive length. One more example. In the figure below, we have some labeling to do. QS is 13. QR is 4. And RS is 12. We are asked, is segment RS tangent to the circle? Well, if it is tangent, it would make a right angle right here. We don't know if it does or not, and we cannot make a decision just by looking. If Pythagorean theorem holds true, then we know it's a right triangle. So we are going to test out Pythagorean theorem. And we're testing this out. Is this equal? 4 squared plus 12 squared equals 13 squared. 16 plus 144 is 160. That is not equal to 169, which means I do not have a right triangle. And segment RS is not tangent.